So I know we didn't get an opportunity in class to go over the actual test that we gave in class, but I thought I'd do so now because I know some of you have questions as to how the answers were arrived at. You actually, turns out you all had the exact same test on that one, so it doesn't matter which tests I go through with you. The solutions will be the same. So at any rate, what we're going to do is we're going to go over the polynomials and radical functions test, see how you did, see what you could have done better, see what mistakes you could have made, and hopefully you'll find your mistakes. And I'm going to model the new test after this one, so it'd be very much in your best interest to go through this and figure out what you did wrong and what you could have done better. All right, brothers and sisters, young kiddies, here we go. Okay. Now, I don't have my graphing calculator because my license ran out, so I have to get a new license for it. But had you taken this on your, and just put this in your graphing calculator, first of all, it's an odd function. That means it goes up and down in either direction forever and ever. It's negative, so it's going to have a generally negative slope. And it's got a y-intercept of 1. So had I done this, I should have ended up with something that looked like this on my graphing calculator. And I ask for the range values. Well, it doesn't matter if I ask you for the range values or the domain values. They're both actually the same in this particular case. The range, it goes up forever and ever, and it goes down forever and ever. Therefore, the range is from negative infinity to positive infinity. And you all need to know that that is the same as all real numbers. That's all she wrote for that one, kiddies. All right, we're going to simplify this. We just did this. I think I did problems like this in the reviews, but I don't remember if we talked about if I talked about in the reviews about this. So I'm just going to remind you about these. And we did talk about it. If I gave you something like x to the 2/3, we said this is the root, this is the power. So another way to rewrite this one would be x squared, because this is the power, and the root goes out front. This is the root. And the roots go in the denominator. So if I give you y to the 3/7, and I told you to rewrite that, well, out front goes the root. Roots are in the denominator. And inside goes the exponent, y cubed. Or I can do it backwards, and I can say, okay, let me give you to the 10th power out here. It doesn't matter what number I put out there. And x to the 4th inside. Well, this will give me x. The roots go in the denominator, or the root goes in the denominator, and the power goes in the exponent. So having said all that, when I convert this problem, I get x, the root goes in the denominator, 5, and the power goes in the numerator, 3. 3/5. Oops, I wanted to do these in yellow. 3/5. All right, moving on. What is the domain? Well, the domain is what makes the function undefined or a non-real solution. What value would I put in here, or values would I put in here to make this a problem? Well, the problem is underneath the radicals when we have imaginary numbers or negatives. We can't have negatives under the radical. So we want these to have real solutions. So if I put a 2 in here, I get 0. Okay. If I put a 3 in here, I get 1. That's no problem. If I put a 4, I get 2. But what happens if I put a 1? That ends up being negative. So the answer is x has to be greater than or equal to 2. Now, Had you taken the time and remember what we did with the graphs, if you remember the radical function, this is going to move 2 to the left, 2 to the right, and 3 up. 1, 2, 1, 2, 3, and it's going to look like that. Well, that means the domain starts here and goes forever and ever and ever, greater than or equal to 2. Subtracted from, it's backwards. So what we're going to do is we're going to take this 4x cubed and we're going to subtract off negative 3x squared. Well, that gives me positive 7x squared. So all right, hold on. Let me start right over. Yeah, that probably was really confusing. Sorry about that. All right, so we're going to take this positive 4x cubed and subtract off all this. But there is nothing to subtract off, so it's just 4x cubed. So I know it's got to be a positive 4x cubed. Then we're going to take this 2x squared, and we're going to subtract off negative 3x squared. Well, that's really the same as a plus. So that should need me 5x squared. And I think I'm actually done, because the only one that has that, it would be choice 2. Moving on. Lazy folk picked, I don't even know what you picked on this one. Lazy folk pick weird stuff. Maybe 3, I don't know. But remember, we're going to multiply it by itself. 4 plus radical 5. So these give me 16. Positive 4 radical 5. Minus, oh, this should be plus. Making stupid mistakes, kids. We're not multiplying by the conjugate. We're multiplying by the exact same thing. So 4 minus radical 5. I apologize. That was a brain cramp. 4 times 4 is 16. Minus 4 radical 5. Minus 4 radical 5. And then remember, radical 5 times radical 5 is just 5. Negative times negative, positive. So positive 5. So these make 21 minus 8 radical 5. Choice 1. Moving on. Okay, we just did this in video 10. We cannot leave this in the denominator. So 2 plus I. Now, had you just typed this in your calculator, it would have given you the right answer. You can just type this in and it'll spit out the correct answer, but I expect to see a little bit of work. 2 minus I. 2 minus I. The calculator is a great check for this. So, in the numerator, we're going to do 2, we're going to distribute. 2 times I is 2I. 2 times, or negative I times positive I is minus I squared. Well, remember, this is really just a plus 1. All over, 2 times 2 is 4. Positive I times negative I is minus I squared. Well, remember, this is really just a plus 1. So I should have a 5 in the denominator. There's only one answer with a 5 in the denominator. So we have 2I plus 1 over 5. Well, this is 1/5, and this is 2/5. And there it is. Choice 4. All right, got a lot of distributing to do on this one. So 3x times x squared is 3x cubed. 3x times 2x is plus 6x squared. And 3x times negative 5 is minus 15x. All right, now we'll distribute the next thing. I'll do it in blue. 3 times, negative 1 times x squared is negative x squared. Negative 1 times 2x is negative 2x. And negative 1 times negative 5 is positive 5. I just got to clean things up. 3x cubed. Can't be 1. 6x squared and minus x squared. Well, that's plus 5x squared. Can't be 4. Negative 15 and negative 2. Negative 17x. And I am done. There it is. Moving on. What is the standard form of this expression? Ooh, that's tough. 4 and negative 1 is 3. 3i and negative 6i is negative 3i. Boom, there it is. Choice 2. We're going to rationalize this. We got to write it in standard form. So it's 3 over 5i. We're going to multiply by I over I. So I get, in the numerator, I get 3i. In the denominator, I get 5i squared. But remember, this is negative 1. So it's 3i over 5. We'll put the negative out front. And there it is. Moving on. Oops. Going to do it in yellow. All right. We're going to simplify this. We're going to rewrite this as negative 16 times 5 times x to the 4th. Well, what is the square root of negative 16? It's 4i. And the square root of x to the 4th is x squared. So I end up with 4i x squared, square roots of 5. Moving on. All right, we did this just a little bit ago, a couple days ago maybe. You're going to rewrite this as 2 square roots of 4 times 6 plus 3 square roots of 16 times 6. All right, almost done. Square root of 4 is 2, so this becomes 4 square roots of 6 plus the square root of 16 is 4, so it's plus 12 square roots of 6. Add those up, and I get 16 square roots of 6. All right, solving radical equations. Now, if I wanted to, I could just plug these answers in. I'll give you a hint. If I plug in 2, that's 6 minus 1, which is 1. Square root of 1, is that equal to 2 minus 1? Ah, that looks like it works. If I plug in a 3, let's see if a 3 works. 3 times 3 is 9. 9 minus 5 is 4. Square root of 4 is 2. 3 minus 1 is 2. It looks to me like 3 and 2 both work. But we should check. We're going to do it the right way and just make sure. Squared. Squared. All you had to do is type those in your calculator to see if they worked. This is just 3x minus 5. This one I'm going to double distribute. X minus 1. So I get x squared minus 2x plus 1. Bring everything to the right side. I get 0 equals x squared minus 5x minus, plus 6. X minus 3, x minus 2, and I get x equals 3 and x equals 2. But you have to check both of them. In this case, both work, but you have to check both of them. Oh, the third term of the binomial expansion. Okay, so back to this. So we're going to do 6c0, 6c1, 6c2. That's the third term. Now, if I type 6c2 in my calculator, which I don't have with me, this is 1, this is 4, no, this is 6. I don't remember what that is. So I'm going to, and I don't have the calculator available to do it for me, so I'm just going to do 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, there it is, 15. That's what I need right there, that 15. So it's 15. I thought it was 15, but I just wasn't sure. Let's go 6, 5, 4, 0, 1, 2. And this one goes x, and this one goes -2. All right, I'm almost done. I got 15 here, and I've got, oh, this should be 2y. And I've got -2 squared. -2 squared is 4. 4 times 15 is 60. X to the 4th, y squared. Okay, so on this one we're going to distribute, and I get I to the 5th minus I to the 4th minus 3I cubed. Now, if you remember the I circle, I to the 1st, I squared, I cubed, I to the 4th. This is just I. And this is -1, and then everything else is opposite this. So on this side, opposite this would be +1. On this side, opposite this would be -I. So I to the 5th kind of tricky. It's 1, 2, 3, 4, 5. That's just the same as I. Minus I to the 4th is just 1, so that's -1. And minus 3I cubed. Well, I cubed, this is really just -I. So -3 times -I is plus 3I. So I got an I and I, that's 4I, and a -1. Could have put in your calculator. Would have told you this was the answer. And finally, we're going to simplify this perfect cube. Let's go. 27 times 2. A cubed is a perfect cube. B to the 4th I can rewrite as B cubed, B cubed times B. C to the 7th I can write as C to the 6th times 6 times C. That makes 7. All right. Cube root of this is 3. The cube root of this is A. The cube root of this is B, and the cube root of this is C squared. So I end up with 3AB C squared, cube roots of 2BC. There she is. All right, moving on. Remember correctly, I had arrows on these. So the domain goes forever and ever from left to right, so that's -infinity to +infinity. And I told you that this value down, oh, that's just -9. So this goes from -9 to +infinity. That's it for that one. All right, the conjugate of this was -4 plus 3I. So when you draw, I'll draw the original in green. So the original is -4. 1, 2, 3, 4. Minus 3I. So the original is down here. And the conjugate I'll do in red. All right, done. Simplify a perfect cube. We just did that. 3. 8 is a perfect cube. A cubed A times B to the 6th. Not even that much different than the other problem. Perfect. This is a perfect cube. That's just 2. This is just A. And this is just B squared. So I end up with 2AB squared, square roots of, cube roots of, so you just forgot that cube, A. And that's an A, by the way. Moving on. This was probably the simplest problem on the whole page. All you had to do is subtract the 44, so I get 16x to the 5 halves equals Again, I don't have a calculator with me. 556 minus 44. So that's 215. So 512. Divide by 16. Divide by 16. And I get x to the 5 halves equals, I don't remember. I don't remember what this is. 512 divided by 16 equals 32. So equals 32, that's right. Equals 32. All right, and I'm almost done. I just got to do the last step, which is to raise this to the reciprocal, which is 2/5. So I get x equals, now if you just did that in your calculator, it'd pop out 4, but the 5th root of 32 is 2. 2 squared is 4. So you can just type it in your calculator, and it will give you 4. That's it for that one. This one I expected to see long division. I expected to see long division. It's what we practiced, what I was looking for. X cubed plus, so I took off some points, I think, if you didn't do it this way. So, this is going to be x squared. That gives me x cubed plus 5x squared. We're going to subtract. So I get negative x squared minus 25. So I'm going to subtract, I'm going to put a minus x. So I get minus x squared minus 5x. Now I'm going to subtract, which turns this to plus, turns this to a plus. So I get negative 20x minus 100. So minus 20. So I get negative 20x minus 100. And when I subtract here, everything goes to 0. So I asked what the other factors were. All I wanted you to do was factor this. And I said only an algebraic method solution. I didn't want you to factor it. I just wanted an algebraic solution. I wanted you to see this division. So x minus 5, x plus 4. Boom. That's the answers. What are the other? Well, factored completely. The final answer should be x plus 5, x minus 5, x plus 4. That should have been the final answer. What is the fourth term of the sequence? So 7C0, 7C1, 7C2, 7C3. This is 1, this is 7, this is 21. I think this is 35. Let's go back up to my little thing that I was drawing, since I don't have my calculator with me. There it is. This would have been 20, this would have been 15, blah, blah, blah. Then I go 1, 7, 21, 35. So 35 is what, in fact, what I need. Parenthesis, 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 parenthesis. So I'll need my calculator in a minute for this one. 7, 6, 5, 4, 0, 1, 2, 3. So this goes 3x, and this goes negative y. So I know my answer is going to be negative something. 3 to the 4th is 81, and 81 times 35 is 2,835. Well, it's negative because of this negative cubed. X to the 4th, y cubed. Moving on. All right, so we have to isolate the radical. We're going to bring the 3 over. So I get 2 x to the 4th plus 5x squared equals 12. Then I'll divide by 2. So I get x to the 4th plus 5x squared equals 6. Now I'm going to square both sides. So I get x to the fourth plus 5x squared equals 36. Now I'm going to bring everything to one side and factor it. So I get x to the fourth plus 5x squared minus 36 equals 0. Now, the factoring here is not overly difficult. X squared plus 9 minus 4. 9 times 4 is 36. 9 minus 4 is 5. So this one I can't do anything with. This one is just x squared plus 9. But this one is x plus 2, x minus 2. So I actually get 4 answers. X squared equals negative 9. So I get x equals plus or minus 3i. Here I get x equals negative 2, and here I get x equals positive 2. So you needed to check all of your answers. I don't have my graphing calculator, so that's going to be a little bit tricky for me. I'm not going to go through that today. That one I just stow and check. All right, so what are we doing? We're moving to the left 7, and we're moving down 4. Boom. Now you could have just typed this in your calculator, got a table of values, graphed them, boom, done. Or you can just do it my way. Move to the left 7, down 4, and we're going to move to the right 1, but we're going to go up 2 because of the dilation of 2. We're going to go to the right 4 and up 4 because, again, instead of going up 2, we're going to go up 4. And then we're going to go 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Instead of up 3, we're going to go up 6. And we actually can get one more in here. We can get 16 in here. That's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then instead of going up 4, we're going to go up 8. And so that is what I expect you to graph. So, in interval notation, the domain, negative 7 to positive infinity. The range, negative 4 to positive 4. I'm going to go back up and check those other ones. I don't like that. I'm going to check those. Is it a one-to-one function? Yes. Passes. Both. Passes. Both. Vertical line test and horizontal line test. And then I just got to plug 20 in. So that was f of 20 equals 2 square roots of 20 plus 7. This was a square root, right? Minus 4. Well, this is really 2 square roots of 27 minus 4. And this is really 2 square roots of 9 times 3. The square root of 9 is 3 minus 4. So I get 6 square roots of 3 minus 4. All right, I'll go back up and check these. That bothers me. I didn't do that. All right, so we're going to check x equals 2. Two to the fourth is 16 plus 20 plus 3 equals 15. So this is 36. The square root of 36 is 6. 2 times 6 is 12. 12 plus 3 is 15. So that works. Now I'm going to try x equals negative 2. Let's see. Negative 2 to the fourth is still 16. Plus negative 2 squared is 4. 4 times 5 is 20. Plus 3 equals 15. So negative 2 works. Now I'm going to try x equals 3i. This is where it's going to get a little weird. Again, I probably would use my calculator. 3 to the 4th is 81. Three to the 4th is 81. I to the 4th is 1, so this is just 81. Plus 3i squared is really 9i squared, which is really negative 9. Negative 9 times 5 is negative 45. Plus 3, does that equal 15? Um, 81 minus 45. What is that? Is that negative 36? Again, I would just use the calculator to check these. These are just way too crazy, and I don't have the calculator available to me. These are way too crazy. Anyway, I'm not going over those. Not going to go over those. All right, that's the solutions to this. Peace out, sisters and brothers. Adios.